Okay, class. If you want to, I want to cover a couple of topics. The first one I want to cover is absolute value, equality, and inequality. It's important, and I'm looking at you all, pay attention to that. There was a question regarding a specific absolute value inequality. I will quickly refresh your memory as far as what we did with the absolute value. And then we will look at the specific question. And here's what we did. Absolute value of x equals k. When k is positive, we said x is what? Do you remember? Plus minus k. Why is that? Because absolute value is defined as what?
From 0.
Absolute value is known is to be distance from 0. What does it mean? Here's how we define it. X, absolute value of x is x. If x is larger than or equal to 0. Absolute value of x is minus x if x is less than 0. Now everybody knows absolute value of 1, for example, is 1, and absolute value of negative 1 is also 1. In the first case, you just drop the absolute value sign. In the second case, what is the meaning of negative x is the opposite of x. So what you really do here, you write the opposite of whatever is in there, which gives you positive. So that's how absolute value is defined. Now, having said that, if absolute value of x equals 5, then x can be positive 5 and negative 5, right, class?
Yes.
If absolute value of x is less than k, and remember what's going on with that case. First of all, this is 5, and this is negative 5. So absolute value of x equals 5 gives us those 2 points. But absolute value of x is less than 5 refers to points whose distance from 0 is less than 5. Therefore, anywhere between 0 and 5, or for that matter, between negative 5 and 0. The part in blue is the answer, right? If we are looking at absolute value of x larger than k, then we're looking for points whose distance from 0 is more than 5. Anything beyond 5, or for that matter, negative 5 will do the job. So absolute value of x is larger than 5 would be the red part. Now, in the case of a blue one, we write x is between negative k and positive k, or for a specific example of x, absolute value of x less than 5, x is between negative 5 and positive 5. In general, absolute value of x is larger than k. That means x is less than minus k, or x is larger than positive k, which gives us x less than negative 5, or x is larger than positive 5. And as far as you're concerned, you have to remember the three cases. We have the equality, we have less than, we have greater than. With each piece, we can graph, and with each piece, we can write the interval format. For this case, the interval format is from -5 to 5. Both of them take parentheses, that means open, because the end points -5 and +5 are not equal. In this case, x is less than -5, that means go from -infinity to -5, union 5 to infinity, when x is larger than 5. So, here's the inequality, here's the solution. Here's the inequality, here's the solution. Here's the graph, here's the inequality. Now, when you're given a question that was given to you in take-home test, which reads the absolute value of 2 minus x over 4 minus d is larger than or equal to 5. First of all, this was the question, right? This is the take-home question. The first thing we need to know is which one, which category, which case do we have to use. So if we look at the three cases that we have, which one should we choose? First and foremost, we have to isolate the absolute value to make a decision. Is that right?
Yes.
So what do we get when we do that, everybody?
You need to add 3 to both sides, right?
Perfect. So what do we get?
That's 8.
So you move the -3 to the other side, meaning you add +3. Does everybody agree with that? To both sides. Now, this is extremely important, class. Please do not touch the absolute value until it's completely isolated. Now it's clearly the third case, right? So we have two inequalities, right? 2 minus x over 4 is less than or equal to -8, or what? The same thing, larger than or equal to. So, you drop the absolute value, and once you say it's less than the value that you see on the right side, and once is larger than that. In this case, we also have the equality sign, so we keep it, that's all. Okay. Now, to solve this, there are a number of ways. One would be to move the 2 and then multiply by 4. You can multiply by 4 now, it makes no difference. But if it's easy to move the 2, that means you what?
Subtract 2, so it would be
Subtract 2. And so what do you get? Negative x over 4, right? Less than or equal to what? We want to solve for x.
Multiply both sides by 4, right?
Multiply by?
Both sides by 4.
You can multiply by 4, or you can multiply by -4 in order to get rid of the negative sign, right? Because even if you multiply by 4, you end up with -x, and that's okay, except you have one more step, right? So if you multiply both sides by 4, the left becomes x. Everybody agrees with that?
If it's negative, that's when you go by 4, right?
If you multiply by negative.
Okay, negative.
Yeah.
Okay.
If you multiply by 4, you get negative x. And then what do you get? You get -4, right?
And you have to divide and do this extra step.
Anyway, so it's up to you. Class, you can do it in one of those steps. So if you're multiplying by negative 4, in one step you get the x, is that right? So what's the right side? 40. Okay. Now we have the sign less than or equal. What happens to it? So we want to pay attention to that. Is that making sense? Okay. Now let's go to this piece. Again, you move the 2, right? You move the 2, that means what? You subtract 2. What do you get? Negative x over 4 larger than or equal to what? Again, we can multiply by 4 or negative 4. Is that right? So again, 2 moves to the other side, or you can say I'm going to subtract 2 from both sides. It has the same meaning. Correct, everybody? And so we end up with negative x over 4 larger than or equal to 8 minus 2, which is 6. Next step, multiply both sides by negative 4. Again, you end up with x here. Let's write it down. X here and negative 24 on the other side, right? And so what happens here? Again, it flips over. Why we are dividing by negative. So be careful whenever you're dividing by a negative number, or you're multiplying for that matter, with an or statement. So maybe rewrite this up here. I highly recommend you go from smaller to large. If you wrote it the way it is, it's just perfect. There's nothing wrong with it. But if I were to rewrite it in this corner, actually, I would write x is less than or equal to negative 24, or x is what? Larger than or equal to 40. I will box my answer, and I will continue, if I'm asked, to come up with the graph and the interval notation. We're going to do that just to be on the safe side. So if I were to graph this, when you look at this one, simply pass. This is 0, and you have to count 24 ticks on the left side, right? So let's assume this is negative 24. Is it solid or hollow? Because the equal. And you start counting 40 tick marks, and again it's solid, right? So to the left of negative 24, to the right of positive 40 would be the graph. Interval notation, negative infinity, comma, negative 24. I use parentheses or bracket. Union 40 infinity. So let me just quickly make sure it's captured here. So the answer is x is less than or equal to negative 24, or x is larger than or equal to 40. Therefore, this is negative 24. This is 40. Negative infinity, negative 24. Union for the infinity. For numbers negative 24 and positive 40, use brackets. Infinity and negative infinity are concepts, we don't. So that's the absolute that you need. Go ahead.
I'm sorry, so then for the 40, it's a bracket?
Yes. I thought I'm sorry. Yes, it is a bracket. Absolutely. The reason why you have the equality. Yes. Both of them. So this is the absolute value equality and inequality in a nutshell. Everybody is okay with that? Is there any question? Yes.
So going back to the original problem, we
Yes,
actually
sir.
broke it down to two
You're
different
welcome.
regions.
Absolutely. The two, we break it into two inequalities. Let's go back here.
Now, I just want to ask a question about the sign right there.
Yes, sir.
So when you're turning that 8 to negative, you're gonna automatically flip the
Yeah,
inequality.
less than, because if we look at this one, and the justification with the simple number 5, when we say absolute value of x is larger than 5, what does it mean? Distance from 0 is more than 5. Obviously, beyond 5, the red portion is the answer, which means x is larger than 5.
So,
Obvious. At the same time, anywhere to the left of point -5 also has a distance more than 5 points from 0. So also this portion. Now this portion is shown here, x less than -5. And this portion is shown here. So whatever inside the absolute value makes no difference. It's less than after you isolate. It's less than -8. That's one piece. And then larger than or equal, less than or equal to -8 is one piece. Larger than or equal to +8 is the second piece.
I understand why that is, but what's the reason for switching it? Is it just a rule to do it?
It's the rule. And here, see what we did with this simple example, we showed why the rule works. In a sense, this is the reason behind it. If you have absolute value of x larger than 5, how do you go from an absolute value to a compound inequality? Those red pieces is the answer. Do you agree with that?
Yes.
Now, what is this? This is x less than -5. What is this? X is larger than 5. Now, how did you get here? What you do, you cut this into 2 pieces. X is less than -5, or x is larger than +5. In other words, this is identical to this. After your absolute value has been completely isolated. 2 parts. Does that make sense? And that's something you need to know with the 3 cases that were mentioned. Case 1, we have the equality. Case 2, we have the inequality when it's dealing with less than, and it becomes a sandwich between the 2 numbers, right? And case 3, absolute value is larger than k, and remember, in all cases, k is taken to the bottom. Then you come to 2 pieces. Good. Now, and you remember when k is negative, what happens? Just to refresh everyone's memory, I'm going to erase this, and then we move on to the next part. Now, when k is positive, this is what we get, right, everybody? What happens when k is negative? And we start with a simple example. Absolute value of x is equal to the same number we used, -5, as an example, right? What's the answer? No solution. Or use the notation, right? Do you remember that? Because absolute value by definition is distance from 0, so how can it be negative? And it's not -5 that is important. Negative any number, -0.1 or -8 works the same way. Now absolute value of x is less than -5 the same way. Does that make sense? And again, -5, or for that matter, -2 or negative, right? So we are saying we are looking for points whose distance from 0 is less than -5. How can it be? Right? Do you remember that? And if we look at this case, absolute value of x is larger than any negative number. You know that absolute value in the worst case is 0, isn't it? Absolute value is either 0 or larger, isn't it? So what would be the answer here? Everything goes. All real numbers. All real numbers. That would work. Sounds good? That's the end of the absolute value equality and inequality. Okay? We're going to go over the next talk. different, right? We're going to look at a couple of word problems or applications. The first word problem that was asked was regarding the mixture problem in your take-home test. Could somebody read that question for us? So let's do a mixture problem. Go ahead, please.
John leaves his house at 7 a.m. His sister Mary leaves the house at 8:30 a.m. and tries to catch up with John. She is walking 2 kilometers per hour faster than him on the same.
That's a motion problem. I will do that also since you, but since I put up mixture problem, let's look at the mixture problem, then I go over, if you want, I can cover that motion problem as well. Let's do both, okay? How about that? Do me a favor, read the mixture problem since I put that, if you don't mind. Thanks.
Number 10.
Yes, please.
A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, he has 80% and a 40% acid solution. How many liters of each in stock solution should he make to prepare a 10-liter mixture? Yeah.
So that's the one.
Yeah.
Everybody knows that's question number 10 from the take-home test, right? We have two types of solutions, class. The first one, what is the strength of that? What is the percent of acid in there? The first one, what was it? 48%. Now, you can either use 48 or just 0.48. As long as you're consistent, then it works perfect. So let's say 48 or 48%. The second one, what is the strength? What is the percent of acid in it? The second one is? Go ahead.
80%, right?
Yeah, the first one is 80 and the second one is 40.
Okay, so the first one is 80%. The second one is 40%. So when we get the mixture, what do we get? When we mix them together, what do we get?
48% acid solution.
How much of it?
10 liters.
So the units. So the volume is that we get 10 liters of a mixture. Everybody agrees with that? So anytime you do a mixture problem, a table like this will do the job. So, we don't know the volume for any of it. So if we choose X liters to be the volume for the first solution, then how many liters do we have for the second one? 10 minus X. And what's really important is, notice if we add these two, we get the total. And that's really the key behind any mixture problem. The total. Volume, it could be investment. The total stays constant. So when we add these two, it becomes 10. Now, again, a common mistake would be that some people would write X minus 10. It's important to understand, when you add them up, let's do it here. X plus 10 minus X versus X plus X minus 10. Are you with me? What is the first one of it when you add them up? 10. What is the second one? Add them up. 2x minus 10, isn't it? And that's not what you're looking for. You're looking for 10. Therefore, it's 10 minus x. They do not add up to 10 if we use x minus So in fact, if you ever get confused, all you have to do, okay, just add them up. Do you get to 10 liters or not? Sounds good? Now, how much acid do we really have? Or you can say pure acid. In this case, you have 80x, or better yet, 0.8 times x, right? In this case, you have 40 times 10 minus x, or better yet, 0.4 times 10 minus x. And the total amount of acid is constant, it doesn't change. It's 48 times 10, or you might say 0.48 times 10. And they add up to give us the total amount of pure acid. So 80x plus 40 times 10 minus x is equal to 48 times 10. Is that right, everybody? All right, so what do we have here? It's when you get here, as I mentioned, you really have done most of the challenging part, and you get 50-60% right here. So let us solve this equation. Help me out. So what do we have? 80x what? Plus 400, right?
Minus
40x. And the right side is just 48 with a 0 next to it, right? 480. Now, 80x and minus 40x, they give us 40x. I can move the 400 to the other side, and it becomes what? 8. Therefore, dividing by 40 will give us x equals what? 2. Let's go back and answer the question. So what do we need here? We need 2 liters of what? 80% solution, and what? 10 minus 2, which is 8 liters of 40% solution. Does that make sense? The key is to set up this table right, and it will always work. Go ahead.
I'm sorry, is this table like amount times percent equals quantity?
No, that's some. It's not exactly like that. When you're looking at a mixture problem, you have to see what the keyword is. In this case, you're mixing 2 different solutions. One is 80%, one is 40%. Now, what matters is that the pure amount of acid, base, alcohol, you name it. Whatever you have, the pure amount will remain unchanged. You can't change the fact that you have 80 times x, in this case 0.8 times x, is the amount of acid. For example, if you have, let's make it an easy number. If you have 100 liters of 30% acid, there's a 30% acid solution, sulfuric acid. We have 100 liters of that, right? How much pure acid do we have? If it's a 30% solution, what does it mean? Only 30% of it is pure. So if I have a total of 100 liters, 30 liters of pure acid, and the other 70% or 70 liters is not acid, and by the way, it's water. Okay. So that's the meaning of concentration when we look at pure acid, pure alcohol, or you name it. So the pure amount is acid, and the rest is water. Go ahead, please.
So x equal to what? How would you describe that as being the answer?
X, okay. The answer is you need 2 liters of 80% solution to be mixed with 8 liters of 40% solution in order to make up a mixture of 10 liters with a 48% acidity. 48% acid. Is that making sense? And notice what happens. If you have 80 and 40, it goes down to 48%. The number that you have here must always be somewhere in between, right? Let's even add to it more intuitively. Class, take a look. Is number 48 closer to 40 or closer to 80? Closer to 40. So you need more of which one? You need more of 40%. See, you have 8 liters of 40% and 2 liters of 80% because it's closer to 40. Right.
So if we solve the problem, and we get something that's, when we add the two together, it's more than 10, we know the small.
First of all,
or the one we get.
First of all, if you come up with more than 10, you made a mistake somewhere.
Okay.
Secondly, intuitively now, because my number, the mixture, is closer to this guy, I need more of that.
Okay.
So intuitively, you know you have to have more here. Now, just for the sake of argument, if it was 3 and 7, you may not know it's incorrect. But how do you know it's incorrect? You have to put it back into the original. And here's how you check it. You multiply these two numbers. Are you with me? And you multiply these two numbers, and you must come up with that. What is 80 times 2, everybody?
160.
What is 40 times 8?
320.
320, am I right? What is 48 times 10? If you add them up, do you get 480? Let me just consider this line. If you add up these two numbers, you get 480. That proves you haven't made a mistake. That's how you check it. Sounds good? Everybody? They add up to 480. Go ahead, please.
So basically, like if you didn't have the table, it would be the concentration times the volume plus the two mixtures together.
But do you see what? Okay, so let's discuss that. This is the percentage or concentration or the strength, whatever you want to call it. This is the amount or the volume of each piece. The product of the strength or percent and the volume will give the pure amount of acid. Okay. Now, the pure amount will never change. Does that make sense? So if I have the pure amount for the first one, the pure amount for the second one, they add up to 48 times. And by the way, if you want to be more precise, you really need 0.8, 0.4, 0.48. So you know the pure amount in this case, for example, is 1.6. Okay, so this really is 1.6. This is 3.2, and this is 4.8. What does it mean? The first one, out of 2 liters, we have 1.6 liters acid. Is everybody with me? Pure acid. The second one, out of total of 8 liters, we have 3 liters of pure acid. Are you with me? When we mix them, we get a total of 10 liters. Is that right? Only 4.8 liters would be pure acid. So that means 48% straight. Sounds good to everybody?
Yeah, I can see right there. I'm gonna take a
Sure,
picture.
absolutely, absolutely. Please, go ahead.
So every word problem is going to have a different setup.
Absolutely. However, a mixture problem, almost without exception, is this. Now, here's what you have to pay attention to. If you look at these items, okay? When you set up a mixture problem, those items must be filled up. If any of them is missing, you put X for the sake of argument. Maybe I know I have an 80% solution, I have a 48% result, but 40% is missing. I'll put the X. Okay? Maybe I know I have 2 liters here, 8 liters here, I don't know how much I have here, I should know 2 pleasant is there. Okay? So understand the first and the second column is what you fill up, according to your reading, according to the translation. The third one is simply by the fact that you are calculating the pure amount by the laws of chemistry. But the first one and the second one you fill up. For a mixture problem, it's always like that. Does that answer? Go ahead.
So you just have to memorize the equations, like say you're doing a distance problem, you just have to
Distance is
remember-
d equals RT. Obviously, there are some basic idea we should memorize. For example, when you do motion problem, we need to know d equals RT, and if we don't know that, obviously, it won't work. Yeah, see, there is some formula that we are supposed to. But more importantly, when we understand it, then we really have to understand why that's the way it is. And in that case, in fact, the motion problem is a lot. I'll explain that for the class. We will look at that on this. But yes, there is a need when we do word problems to know some basic formulas. Sounds good? Now, if they give you any mixture, and you set your table right, it will always work without exception. And you need to practice. All right. Let's go to the motion problem. Any questions before we do? Motion problem. Everybody knows if we are driving, let's say, 50 miles per hour on the average, and that's really the key, on the average, over the course of, let's say, 4 hours, we cover the distance of 4 times 50 or 200 miles, right? And the key word is the average speed, because obviously when you're driving, it may be stop and go, you know, you speed up, you slow down. So on the average, we did 50 miles an hour, 4 hours, we got 200 miles covered. Everybody is okay with the first formula, right? Now, with the first formula, we should also know the second and the third. In other words, the rate is distance over time, and the time is distance over rate. We'll see more of motion problems later on, and we really need to understand this concept. So as long as we know d equals RT, and therefore the second and the third formula, then we are set to go with any motion problem, and the setup is the same. Rate times time is distance, and something is missing. Go ahead, please. Read the question that you have. You were reading for the table.
John leaves his house at 7 a.m. His sister Mary leaves the house at 8:30 a.m. and tries to catch up with John. She is walking 2 kilometers per hour faster than him on the same route in the same direction. If they both kept on the same route, Mary could reach John 3 hours after she left. Find John and Mary's speed.
All right. Let's see, as we read the question, what we can come up with. And when you do word problems, you have to read them a number of times to be able to translate. So there is something given about the time, about the speed, and a relationship you can make up. For example, when they discuss the speed, what do they mention as far as their speed is concerned? John and Mary. They said something about the speed.
It just, I'm
Yeah.
sorry, it says that she's walking 2 km faster, so then John would be X, and then.
So if John is doing X, and let's write mph, miles per hour, and so Mary must be doing what?
X plus 2,
It was miles per hour or kilometers?
KN.
Okay, so that's what we know about the speed, right? The rate. What do they tell us about the time? Let's read it once more, the sentence that explains the timing for both. Go ahead.
John leaves his house at 7 in the morning. His sister Mary leaves at 8:30 in the morning, so she leaves an hour and a half later than he does. And it says that they need, she could reach him in 3 hours. Wait. Mary could reach John 3 hours after she left.
So if we are looking at the timing, what should we write? So John leaves at 7 a.m. Mary leaves at 8:30 a.m., 1.5 hours later. And she meets up, she catches up to John in 3 hours. Right? Everybody's clear as far as what you're telling us? So tell me, what can we say about the timing? What's the timing here? 3 hours. So in 3 hours, Mary catches up with John. So what about the timing for John? 3 plus 1.5 or 1.5 or 4.5, right? But do you see the reason behind? I highly recommend you write 3 plus 1.5 rather than just 4.5. So you see why this is the case. So the 3 hours that Mary has been traveling, or I don't know, walking, jogging, the same thing happens with John. However, he started at 7 a.m., so that's the 1.5. Do you see that? Which gives us 4.5. So what is the distance that John has covered? John has covered 4.5 times x. Is that right? What about Mary? Mary has covered what? 3 times x plus. Now, the first one is the distance John has covered. The second one is the distance Mary has covered, and there is a relationship between the two distances. And what is that? They must be equal. So as you read the question, you realize they must be equal, or at some point you may add them up. Depends on the situation. In this case, they are equal. And when we have this,
Wait, isn't Mary's rate twice as much as John's?
just you didn't say twice. Do me a favor. Read the sentence so we can translate it. What was the sentence?
She is walking 2 km faster than him.
So it's x twice. So everybody is okay with the setup as we look at the table, and then the equation. Make sense? So now 4.5x is equal to what? 3 times x and 3 times 2. Subtract the 3x. You get 1.5x equals 6. Divide both sides by 1.5, everybody. What do you get? So therefore, John is doing 4 kilometers per hour, and Mary is doing 4 plus 2 or 6 kilometers per hour. Is that making sense? How do you check class? If we were to check it, how do we check it? We just check it here. What is 4.5 times 4, everybody? What is 4.5 times 4? 18. Can somebody give me the units? 18 what? No. What is 3 times x plus 2 or 6? And it better be the same. Otherwise, we made a mistake. A motion problem requires this type of thing. Now, after you set up a table, you have to see what's the relationship as far as the distance is concerned. They add up, they are identical, or there may be a relationship as far as the time is concerned. You have to just read it a couple of times. And with a few word problems, you really get the hang of it. It's very simple. It's mainly translation. Sounds good? Any questions? We get ready for the next word problem that was asked. All right, here's the word problem class. It's about sort of rental, when you rent a car or something like that. There are two different companies, and the way the rental works is that they have some initial fee. Sometimes they have a fee per day. It depends how the question is. And then they have some, cost per mile involved. It depends how they charge. In this case, there are a couple of companies. So we have company A, and we have company B. So here's how they charge. The initial cost when you rent a car or truck or whatever the case might be from company is that they charge us $87.50. Okay? They also charge us 40 cents per mile. So the first company charges that. The second company, they charge us 60 bucks initially. And in addition to that, they charge us 90 cents per mile. Now, there are different types of questions they might ask. Okay, at what point one becomes advantageous, or at what point they break even, and so forth. No matter how they ask you, the first thing you really have to figure out at what point they break even. Go ahead.
Can we set this up as a linear function?
Yes, absolutely, 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 and that's what we're doing. So now, when we say at what point they break even, that means how many miles are we going to drive to break even, meaning company A charges identical to company B, right? So we can let what? Any variable be what?
To the 47.
Let X or M be the number of miles driven. So if we let X be the number of miles we are going to drive, what would be the cost associated with the first company? Total cost, okay? So this would be, let me just rewrite this. The total cost. So what would be the total cost associated with the first company? 8750 plus
48.
0.4 or 0.40x. Is that right? What is the cost, total cost, associated with the B company? Company B,
60 plus 0.90x.
60 plus 0.90 or 0.9x. When we say break even, we mean they must be identical, right? Does that work for everybody?
Yes.
Now, again, as an intermediate algebra student, you can handle it in the following manner. We are going to move the 60 to the other side and 0.4 to the right. Right, everybody? And what do we get here? What is the left side? 17.5x, right, class? What is the right side?
Isn't it 27?
27.5. 27.5. And the right side is
50x.
0.50x or simply 0.5. Now, to solve this, we divide both sides by what?
0.5. Which gives us x equals 55, if I'm not mistaken.
You're right. Division by 0.5 or 1/2 is the same as multiplication by 2. Or move the decimal 275 divided by 5. So when we go 55 miles, both companies charge us the same. Do you all agree with that? Does that make sense? Now, if you know you are going to drive 55 miles precisely, it doesn't matter which company you go with. Do you all agree with that? But let's say you know you're going to go more. You're going to go at least 100 miles. I don't know. I'm just making up something. More than 55 miles, if you know it. Which one would be a better deal as far as you're concerned as a consumer? Would you? The first one? And again, you can pick up any number, even 56, 60, 80, 100, and plug it in and calculate. The reason it becomes advantageous because they charge less per mile. You see that? So if you drive more than 55 miles, this becomes a better deal, meaning less costly to you. On the other hand, if you are going to drive less than 55, the second one is a better deal. Is that making sense with you? So better deal meaning less money out of your pocket, of course, right? So depends on how the question was asked. Sounds good? Any questions? Now again, these are different types. If you really practice with different types of problems that are given to you, for example, a mixture problem, you do a fluid motion problem, or for that matter, you're going to look at some geometry problem. Okay, I'm going to give you some formulas to differential number. Let me look at maybe an example. Any questions? Yes.
So the best thing is when you do a word problem is to first set up the table so you get all the
Absolutely.
information, right?
Yeah, but you know, you really have to read the question a few times. You really shouldn't start with any word problem after you read it once. That's not enough. I have to read it a number of times. If I understand what you're asking, then I set up the table. And a table does wonders. It always works. You really don't want to start without a table. And the reason being, even if you understand the question now, later on you're going to have a problem. Okay? All right. I'm going to go over some basic formulas to refresh everyone's memory as far as geometry is concerned. Okay? Some of the shapes and how we come up with the area and perimeter, and a few shapes as far as the volume is concerned. So let's start with a very basic one. Class, what is the name here? What's the area?
Left times width.
S squared.
That's square.
Yeah, length and width are identical. Therefore, S squared, right? Area is like, carpeting the room, for example. That's the meaning of carpet. Perimeter, that means going around, that means like fencing. So, perimeter is 4 times S. Is that right? What about this guy? So what's the name? Rectangle. What's the area?
Left times width.
And the perimeter?
Is 2L plus 2W.
Okay, what do we call this? Triangle. What's the area equal to?
Half the base times the height.
Perfect. And the perimeter is simply add up the sides, right? Remember the name? It's a parallelogram. The area is equal to base times the height, and the perimeter would be 2 times A plus B, or 2A plus 2B. We looked at this piece last time. We don't have to do this. What was the name? Do you remember that? So the area is, do you remember that? We went over this last time. 1/2 the height times B plus B. In one way to understand it, this will cut the area in half. This will cut the area in finding the problem of area from two different triangles. The top one and the bottom one.
It's not B plus B.
B plus B. That means we have two different bases. Okay. Lowercase b and uppercase b. Sometimes they use 1/2 h times b1 plus b2. That means the same thing. So one of them they call it b1, one of them they call it b2. The parameter is simply add them up. A plus b plus c plus factor. Okay. This one I'm going to keep it because we're going to go over that. This one is a circle, right? What's the area?
It's 5 times r squared.
Perfect, right? And we call it the circumference. Circumference is equal to?
2
pi.
5 1.
Now when we use pi is a precise number. When we use 3.14, it's an approximation. 3.14 is an approximation. A couple of geometric shapes that you are familiar with. This is what? A cube, right? Where the volume is S times S times S, S cubed. And the surface area is 6S squared. Let me just make sure everybody understands what's going on. If you happen to have, if you look at this room, for example, it's a rectangular solid. If the width, the length, and the height are identical, we call it a cube, right? So if you're looking at this room, let me just draw the other one also. Okay. Now, the volume is basically the area of the base, which is length times the width, times the height. And that works the same thing, the same way for a cube or a cylinder. Now, the volume in all cases, class, is the area of the base times the height. So what is the area of the base for a cube? S times S, S squared, right? The area of the base, here's the base, right? What is the area of the base? S times S, right? And what is the height? S, therefore it's S cubed. Do you see that? Look at this case. What is the area of the base? Width and the length. So length times the width. And then times the height will give you the volume. Is that right? So if you're looking at a cylindrical shape, what is the area of the base simply? R squared, right? Times the height. Do you see? They all work very similar. In all cases, What is the volume? The area of the base times the height. Area of the base is S squared, so times S is S cubed. Length times width times height, because length times width is the area of the base. And in this case, pi r squared times h, because the area of the base for a cylindrical shape would be pi r squared. So area of the base, area of the base, area of the base. Do you see that? Now, the surface area, is the same as gift wrapping everything, if you will. When you want to gift wrap this one, you look at one side, doesn't matter which side, and the area is S squared. How many sides does it have? 6 of them. Is that right? But if you're looking at a rectangular solid, for example, this room, if you look at the area of the base, then you have 2 of them. If you look at the area of the wall behind me, you have 2 of them, right? And if you're looking at the area to the right, there are 2 of them. Therefore, this surface area is 2 times n times the width, n times the height, and width times the height. In any order, it makes no difference. There are 2 of each. So the area of the base, there are 2 of them. Area of the wall, to the right, to the left, behind me, and over there, in front of me, 2 of each. So that would be the surface. Let's see if we can figure out the surface area in such a way so we hopefully will remember it forever, as far as a cylindrical shape is concerned. Okay. If you're looking at a cylindrical shape class, surface area refers to what? Gift wrapping. So what is the area of the base class? How many of them do we have? So we have 2 pi r squared. You already did that so far? So one more time. The area of the base, and we have 2 of them. Now look at the surrounding, the wall, if you will. Here's what happens, class. Take a look at this, everybody. If we look at this and it looks like a cylindrical shape, the area of the base is pi r squared, and therefore we have 2 of them, right? 2 pi r squared, right? Now, I want to find the area of the surrounding, right? Do you see if I cut it open from here, becomes a rectangular shape, right? If I cut it open, becomes a rectangular shape. Now, if it becomes a rectangular shape, do you see the circumference becomes the length? Open it up. Cut it open from here, right? Cut it open from here. Look at the circumference. Becomes the length, right? And the height remains unchanged. So what is this? The length times the height, if you will, in this case. So what do we have? The circumference, 2 pi r times the height. That would be the surface. Those are some of the basic geometric shapes we should be familiar with. There was a question that I'm going to put up. Consult. Now, before we continue, there are a couple more facts we are supposed to know. Before we move on, when you look at a triangle class, a couple of things I want to add to that we need to know, just to make sure we are okay with that. A, B, C. If we look at the interior angles, What is A plus B plus C? What is it supposed to be when you add them up?
The perimeter of the triangle.
No. I'm looking at this angle, this one,
Oh, 180?
and 100. So that's one fact. So when we are looking at geometry, there are basic ideas we need to know. That's one. Does that work? What else do we need to know? Take a look at this one.
One of them is a right angle, and that's 90 degrees.
So one of them is a right angle of 90 degrees. Anything comes to mind as soon as you see that? Pythagorean theorem, okay? Pythagorean theorem. What is that? A squared plus B squared equals C squared. What does it mean? If I have been given two sides, I can find the missing one. Right, class? Does that work for everybody? Just for the sake of argument, let's say this is 4, let's say this is 7. Do you see that C is wide away. Before even, it is important to know when number 1 is given, then we should know A squared is C squared minus B squared. B squared is C squared minus A squared. Or for that matter, A is the square root of C squared minus B squared. Or C is the square root of A squared plus B squared. They are all really referring to Pythagorean theorem. And so, in this case, this would be the square root of 4 squared plus 7 squared, which is what? This is 16, right? This is what? 49, right, class? And this is 65. Square root of 65 is a precise answer. And an approximation is, you need a calculator, but I hope everybody knows it's 8 something, right? Because 8 squared is 60. So here's the question that was asked. I want to quickly cover that. And then, I was hoping to get some time for lines. I mentioned something about lines. So here's the question, class. If we are to find the shaded area, do you see that the shaded area would be the area of the bigger circle minus the area of the smaller one, right? So pi capital R squared minus pi lowercase r squared. Now in this case, the larger one has a radius, I believe, of 20, and I don't know if the units are given here, but we just make it up. Let's say 20 inches. And the radius for the smaller one is 8. So in this case, the answer would be pi times 20 squared minus pi times 8 squared. So what is 20 squared, everybody?
100.
400. So one easy way to calculate this, just keep the pi the way it is, minus, this is 64 pi. So that gives us what? 336 pi, right? Now if you keep it as pi, this is a precise answer. And of course, what are the units? Inches squared, right, class? But approximation, you have to multiply this by 3.12, and it gives you an approximation. So that would be the shaded area. More importantly, we wanted to see how the shaded area is calculated, which is the area of the bigger circle minus this. Sounds good? And again, I highly recommend you keep the part and then write the approximation. This is the precise answer, this is the approximation. And I'm going to spend maybe another few minutes on the next topic, lines. I want to make sure that the basic is covered. So. All right, let's see what we know about different equations of a line. We have standard form. AX plus BY equals. I want you to know that as far as the standard form is concerned, sometimes you see lowercase ABC, sometimes you see even the constant is on the left. But the point is, number one, X and Y belong to one side, and number two, it's not necessarily a unique equation. Point, slope, y minus y1 equals m times x minus x sub 1, and slope intercept. If we solve any of them for y, we get to slope intercept y equals mx plus b. Everybody is okay with that, right? Now m, or slope, is defined as rise over run. Yes, class?
Yes.
Now, what does that mean? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Right? Is that making sense? When we look at lines, 4 cases could happen. Positive slope, negative slope, horizontal line. What's going on with the horizontal line? The slope is 0. And we also have a vertical line. Slope is what, everybody? Undefined. In the case of a horizontal line, you have this point, which is called the y-intercept at 0b, and it has the equation y equals b. In the case of a vertical line, you have this point called the x-intercept. Let's say the coordinates a comma 0, therefore x equals a. So, in the case of a vertical line, x is constant. X doesn't change. In the case of a horizontal line, y doesn't change. For example, if I gave you 7 and 10 as one point, I said we know a line contains that point, okay? Can you give me a horizontal line which contains this point? What would be the equation for a horizontal line containing this point? What do you think? Anyone? Y equals B. What is y? Isn't y constant? And if y is 10 here, y must be 10 for that horizontal line. What about a vertical line containing this point? Perfect. So that's something you need to know. Does that make sense? Is everybody okay with that? Also, we need to know the following. If two lines are parallel, what is the relationship between their slopes? They have equal slope, don't they? And if they are perpendicular, you can say they are negative reciprocal of each other. In other words, m sub 2 is negative 1 over m sub 1. Or their product is negative 1. All right? Those are some basics you're supposed to know. So, let's look at a very simple example as far as how to come up with the equation of a line and graphing is concerned, okay? So, let's say they have given us 2 points, everybody. 1, 4, and 2 minus, I don't know. We just made up something, okay? In order to come up with the equation of a line, everybody, first we need the slope. Right? And I highly recommend you line them up so you see what happens. Changing y over changing x. And that will give us what? Negative 7. Well, I was hoping to look at that, but that's fine. So negative 7 over 1, which gives us negative 7. To come up with the equation of a line, y minus y1 is m times x minus x sub 1. So I can choose the first or the second point. If I choose the first one, y minus what? 4 equals m negative 7 x minus 1. I'm looking at this point over there. If I choose the second one, becomes y minus minus 3, which is y plus 3. Let me just quickly write that underneath. If I choose the second one, y minus minus 3, and that is mx minus 2. They do not look the same, but if you solve them, no matter what, they give you the same answer. So if I continue for this guy, y minus 4 is minus 7x plus 7. Right, class? And so move the negative 4 because I highly recommend you put it in slope intercept form always. Minus 7x plus 11. Is everybody with me up to here? Now, let's say I come up with the answer and I'm not too sure. How do I check? How would you check your work? How can I make sure I haven't made a mistake? How can I make sure I came up with the correct answer? Anybody? Exactly. And I highly recommend you plug in both points. So if you plug in 1 and 4, negative 7 times 1 minus 7 plus 11 is positive 4. So the first one checks, right? If you plug in 2, negative 7 times 2, negative 14 and 11 is negative 3. The second one checks, you haven't made a mistake. Now class, how do you come up with the graph? You can plot any 2 points, and 3 points is to be on the safe side. Can you use the original points? Yes. But I don't want to use the original points. I want to use important points known as intercepts. All right. Now class, obviously, to find the intercept, x is 0, find y, is called the y-intercept, right class? Which is looking at you, 0, 11, right? And then, how do you find the x-intercept? You set y equal to 0. Is everybody clear as to what we are looking for, right? So, x is 0, that's called the y-intercept. Y is 0, that's called the x-intercept. So, in the first case, it's easy to see it. You set x equal to 0, you get to 11. In the second case, how do you find the x-intercept? You set y equal to 0, right? Right, everybody? You replace the y with 0. So what happens to x? X becomes what? Can you give me the answer? 11%. And then you do the correct tick marks. You go 11 tick marks up. Let's assume this is 11. And then you put a couple of tick marks. 11/7 is what? This is not too straight. 11/7 is what? 1 and 4/7, right? So between 1 and 2 and closer to 1. So somewhere here, that would be 11/7 and 0. Now when you look at this line, you can clearly see the negative slope. Everybody agrees with that, right? The basic definition as far as the concept behind slope is that if we go from left to right, what happens to the wall? Remember, from left to right, everybody, x will always increase, right? From left to right. What happens to y? If the y also increases, we are dealing with a positive slope, is that right? But in this case, do you see that the y decreases, doesn't it? So that's the concept of negative slope. Any questions? Yes?
So you're saying that's considered a negative slope because the y is going down?
Exactly. If you look at this one, if you look at this graph, if you look at this line, look at the blue line. As we go from left to right, obviously x increases, right? But pick up a point, pick up a point, pick up a point. As you pick up any points, the y coordinate is also increasing, isn't it? If x increases, y increases, also we call it positive slope. But if x increases, y decreases, we call it a negative slope. Or this is considered to be an increasing function, this is considered a decreasing function. Any questions, please? All right. That's the end of the session. That's what I electricity.